Hey guys, welcome back. So, solving another stack question is maximal rectangle. If you have watched the video of largest rectangle in histogram, or you know the logic of next greater element, next is little and previous smaller, next smaller, so it's pretty easy for you. I have written code. I not want to write the code, but it's taking too much time to write in code because it's actively uses code. So I don't want to write again. So that's why I'm just explaining this code question only. So here given a 2D array, actually 0 and 1. You have to largest rectangle. You have to given the largest rectangle area with the ones only. Okay, it's not with 0. Like if you can see, imagine this. Just draw a line between this first row. So what you see 1 0, it's actually you can see of the bar 1 0 1 0 1. So you know it's actually representing a bar, and you know how to find that. You have that for each bar you know how to find previous smallest, next smaller, and you know the logic of finding the width. Okay, like from next I minus previous I minus 1 you get the width of that bar, and into the length of that bar you get the area, and then you compare the highest area, you know. Then when you get either two lines, then you get the two lines, you get the this bar it 2, it's actually if this is a 0 it can't be, it's actually 1, it can't be. If there is a 0, current is 0, you don't need to add because it's actually a 0 now, currently is 0. If there's 1, you had to add the previous one. Okay, there's like 2, this 1, this is actually representing a bar. Okay, so if it is representing a bar, you know how to know the large is actually a largest sectogram. You just need to just add a prefix sum, like first you this one, then for this 2, then you this 3 will represent this, then this 4 represent a prefix if. Yes, you have to check if the current value is 0, you don't need to add, it's actually the 0, actually the prefix sum is 0, because if currently is 0 you don't want to add because base is 0, so how you add the upper ones. But if this is a 1, this is 1, this is 1, then it make a heights. Actually if there is a break on the 0, it can't be like something else. Okay, so if there is a break like 0 in the between something like this, it can't be, you can add it or to as 1 is 0 actually. So that's how the largest rectangle you can see like this. If you see this block, it's actually 2 width and 2 height and 3 width, so 2 into 3 6 is the area. So what you have done, you know that for each you have, for each row it's actually representing bars. If you just add a prefix sum, first one, then 2, then 3, then 4, it's actually representing a bar. So that's how you sum. You can check if matrix not empty, it's written 0. Then hiding the rows and column, you make a prefix sum because we need prefix sum for each rows till each row. Like for this row, then till row you need that, till row you add these ones. Then you just check for each prefix row columns, actually array prefix and array you can say. So you know that for this you need to traverse in a 2D matrix by database, and you have to just create prefix sum for like for height 0. If I already say if currently is 0, like something is 0, we are adding for this, it means you have to prefix sum is 0, because if it's 0 there is nothing. If above is 1, it's not been valid because 0 is there, it we have calculated as a 0 only. That's we have taking. If it's not, it's 1, then we calculate the height j, current height, and the like prefix height, and add into the ij minus 0 actually. Okay, okay, so this is how you have to solve for each things, and this is how it's solved. Then for each prefix, like we pass one by one. For like first, like it's make for when I equals to 0, like third this row, and we just make the prefix sum for this row, like in the height j. Okay, we make n, like n row and columns, n rows you can say. If the n row and columns is in there and columns in there, so you just add the n size and prefix sum for this, then you pass check for the largest rectangle, and you know the largest rectangle area. You have to find the previous smallest and next smallest. You have the same code as largest rectangle area, and just do the logic of similarly. So you understand that if you have watched that video, it's pretty easy for you. Then just you check with the max area initially to 0, and you get that. Then again for when you go with this row, then yes, again you know at for 0, then for this again 0, it's, you know, the height 0 already had something value previously, so you add into that. Okay, similarly, when you get 3, you have till that prefixum, you add that current value if it is not 0. So that is how its prefixum calculated 1111 like something, because it's actually hides you things. It's it's already we had declared before. So when it is first down, the first time, it's actually stored for 0 1 2 3 4 columns. Okay, then again for the second row, you have already 0 1 2 3 4. We add the previous ones if its current one is not 0, like it's 1, so previous we add the previous one value, so it's now hide 0 will become 2 for that row, it's 3 for that row, it's 4 for that row. Okay, for that row, that column, you can say, or something you understand better. So this is how you can calculate easily. You have just know the maximum rectangle area code, you know, you have to find for each bars, we have to find the smallest, previous smallest, and we have to find the next smallest. When you know, you have to just L is the current height. Okay, and this is what I said, like if there is minus 1 less, you have to next smallest, you have to set it to the n. I already sent the n. B, you know it's how you find the b, and area is equal to b, you have to check area and return area for each bar. From each bar you have to find similarly. There is nothing new things in their code, but yeah, you have to, for making, like for the rectangle, for the matrix here, you have to make it like a bar. So that's how you are making bar, by making calculated prefix sum for each time, each rows in that, and you just doing that. Yes, we doing this because we have given like character here. You can do with the character here, you have to check like with character there, so that's we need integer value. That's how now we make changes to integer. That's why it's converted from character to integer, and at last you get the largest area. So this is how this question solved. It's hard, but when you know the logic of largest histogram, you can easily solve like this question. Yeah, you maybe you think of the new logic like something different logic, but yeah, if you have the previous logic, it may be some it related to the previous one. So always saying that if you have solved any previous question, that it can help you in your new logics, it can help in this question, you must give a try. Actually, it's really helpful. Like we have solved a lot of question in this series, like series, when you know previously, like you when you get to know a previous smallest, next smallest, you can use in the histogram things and other question, minimum in the sub array, you know the logic of something like that, something some different changes, but the logic is similarly behind it. So that's how you solve that type of question. So must try, must think of the logic, and just practice in the like notebook. Just take a notebook and pen, you can draw the diagram and you can direction with the visualization. If you know the visualization clearly, you can think it's actually a bar, then how you can think of this logic. Okay, actually, so thank you guys, thank you, bye bye.